we are switching over to Ben and Edouard, who will be our interview hosts for the morning. Both passionate about science and the National Jonk Fuerscher contest. They will be chatting to our director of the foundation, Mrs. Susanne Eng, to get a glimpse into the organization of the 50-second contest. Our next presentation is by Arthur Julien and Dennis Kria. They will present a project called Our next presentation is by Arthur Julien and Dennis Kria. They will present a project called avoidance.
We now welcome on stage our first competitor, Mr. Krzesimir Hyżyk from the European School, who is competing for the 5th time in a row with an engineering project. He designed a custom local positioning system for applications in supply chain logistics, inventory tracking, collision advance avoidance, and precision systems. I'm very excited to learn about how he did this. Let's hear it from Krzesimir.
Good morning. I am Krzesimir Hyżyk. I'm from the European School. And for this year's Jonk Fuerscher contest, I have created a local positioning system. A local positioning system is used to obtain the coordinates of multiple objects within the specified perimeter. So this system has many use cases, from the automotive industry, through supply chain logistics, all the way to space and planetary exploration. Now, in all of those cases, the information about the location is important to track the movement of the object. This local positioning system consists of multiple parts. Firstly comes the hardware, which is built on top of positioning and communication antennas. Then comes the software, of which the key parts are the communication protocols themselves, as well as the triangulation algorithm, which I will explain later. Then are the external devices, which are just general devices that are able to use the local positioning data obtained from the server. And then finally, the user interface, which is used to visualize all of the antennas and external devices. So let's start with the hardware. There are two main parts, a client and a server. Each client, this one, is built from the following components: one microprocessor, in my case an RP2040, one low-frequency positioning antenna, and one high-frequency communication antenna, as well as a power supply. For the purpose of this presentation today, I have built 6 of such clients. Then there is also the server, which is the key part of the entire system and is a place where all of the computations are performed. It is also built from one microprocessor, an RP2040 also, and then 2 high-frequency communication antennas, as well as 3 power supplies. Now, let's move to the software side of things. So the triangulation algorithm is the core part of the software of this project, and I will explain how it works based on the following example in a 2-dimensional space with 4 points. On this graph, the location of the pink client is unknown, and it must be located. So, firstly, the entire space is divided into a 4x4 square grid, of which every square is colored based on its calculated error. From there, the square with the lowest error is chosen as the new encapsulating volume. Then, the steps of division and coloring are repeated until the encapsulating area size is within the error margins. Now, onto the final part, the user interface. For the purpose of this project, in order to allow on-the-fly management of the entire system and a very high degree of configurability, the user interface has been created. And now let's visit a real-time view of this user interface, and let me present to you some of its features. So, for the purpose of this presentation today, I have created 3 different demonstrations. Each of them present a different aspect of this project. Let's start with the first one, precision. On the top edges of the stand, there are 2 yellow antennas, and the third antenna, which I'm holding in my hand in this blue box. Now, the server will project the position of this antenna onto the line made by those 2 yellow antennas. The position of the projected point will decide which balloon will explode. As you can see, the balloons are located really close to each other, so the effective precision of the system is within 15 centimeters. So when I align the blue box with the second balloon, it explodes, but leaves the second balloon intact. Now, the same thing can be done with the third balloon, or for example, with the fifth one, or fourth one, third one, or also the last one. Yeah, so as you can see, the effective precision is very high in this system. Now, let's move on to the second demonstration, the robotic hand right here. Basically, this robotic hand was originally built without any antennas. However, it was later retrofitted with one antenna at the end of its gripper and one at its base. As you can see on the screen behind me, there is a tracking of the robot's movements. Now, those two antennas allow for a much higher degree of control during the operation of such robots without having to make big alterations the already existing system architecture, allowing firms not to have to purchase new robots every time. Now, let's finally move on to the last demonstration today, collision avoidance. This scenario will simulate a car crash. However, both of the cars are equipped with collision avoidance software and local positioning antennas. When the red car will move too far, will move too close into the yellow car, it will brake. However, of course, the yellow car won't move, so this won't be a problem. So if I accelerate the red car, it slowed down, slightly late, but it still slowed down. Now, if I reset the car and do the same thing again, the following may happen. So this really simulates how effective this system can be in collision avoidance. And I hope that you could see the potential that this local positioning system holds. And I'm especially proud of its precision, which makes it applicable in many leading industries. So thank you very much for your attention, and I'm happy to answer your questions.
Hello.
Hello.
How are you doing?
Pretty good, yes.
Yes?
It's already better now, yeah.
That's great to hear. You had a wonderful presentation.
Thank you.
With special effects.
Yeah.
I heard
Not
some...
all of them worked this time, unfortunately. There were supposed to be some also fireballs on stage, but that unfortunately doesn't work this time because there are just so many moving parts in the system that not everything works.
Exactly.
Always.
But still, visually it was very interesting.
Thank you.
And as you explained to me, it's not your first time.
No, it is my 5th time here actually. So I have started when I was 12 in 2019 and have done this ever since. So.
Oh, wow, okay. As a veteran, are there any kind of advice that you would give to your fellow participants?
Basically, just I would say just go for it and try to at least do something, because it is the nice thing about this contest is that you always win something here. There are so-called no losers here. Everyone wins something, so it is really motivational for someone who just only starts in science and maybe doesn't know a lot to also win a prize for their work.
That's true, exactly. Now that it's your 5th time, do you plan to be here for a 6th time?
So I have already projects planned for the 6th and 7th time.
Yeah.
They are already in the works. So.
Oh wow! Okay.
And yes, they will also be visual. The one next year will be visual. So also there will be some presentations on stage.
Okay. So a little bit of showmanship and to visualize the science.
To visualize it, yeah.
Perfect. Is it going to be in the same direction as your presentation right now, or is it going to be something completely different?
It will also be engineering and computer science. Mm-hmm. It will be something related to kind of genetic evolution and also mimicking how a brain learns stuff applied to an algorithm.
Okay. I'm pretty sure you have heard that right now there's a lot of discussion about AI, technology, replacing humans, or at least following them, knowing where we are at every moment of our life. Do you share that sentiment, or do you believe there's something positive?
I think that it is a positive because it like really shows how much we have advanced as a whole civilization, that we are able to sort of model not ourselves, however, our language and how we interpret our also sentiment analysis, that we are able to do all of that already, and image generation. So it really shows how far we've come. However, we also have to remember that everything that on one side can be used for good can also be used for evil. So we also have to learn how to find, for example, now there are a lot of problem with fake news range with those algorithms. So we also have to learn now how to filter that.
Exactly. Yeah. Just a general questions. In 5 years' time, where would you see yourself?
Probably finishing my studies. So.
Okay.
Yeah.
And then after that, are you going to stay with science, or?
Yeah, I am going to stay with science, computer science and engineering, and work in that general area.
Perfect. So this is a good basis to jump off and to prepare yourself. Okay. Then as a last kind of moment before we go back on stage, because you have the showmanship, do you think that the visual aspect that you are presenting to us in combination of the science is important, or do you think that sometimes it's better to just stay very academic and just on a presentation?
I would say that it is usually better to have at least something on stage, because personally I think that anything that is sort of tangible makes it more memorable and personal for the jury in this case, or the public when I present somewhere else. Mm-hmm. So I would say that always having a visual aspect that is tangible and physically on stage is always better.
Yeah, do you think also it's going to motivate the young to go more into science when they see the visual representation?
I would say that if they can see what can be done, then they'll be more keen on following it.
Okay, then thank you very much.
Thank you.
And I'm looking forward to maybe see you next year then with one of your new projects. Yeah. And I would say we go back to the stage and see what your fellow competitors are going to show us today.
Yeah, definitely.
Thank you very much.
Thank you.